Welcome to the first recorded lecture in calculus. This is the first of probably 3 or 4 short videos, each with about one example. Today in calculus, we are going to talk about applications to extrema. These are classic problems in calculus where we maximize or minimize various variables. So first, we're going to actually look at a problem that we can first see in a college algebra course. Back in college algebra, wherever or whenever you took it, or even a high school algebra course, we have seen instances where we will try to find the maximum or minimum of a quadratic function. Quadratic functions have a minimum or a maximum. In calculus language, it's absolute. It is the largest or the smallest value. For a quadratic function whose graph is a parabola, we give the name vertex to that maximum or that minimum point. So I'm going to work a problem that I've worked in Math 165 before. I'm going to find the vertex using those skills. Then I will do the calculus version of the problem where we find the derivative. So in algebra land, the vertex will give us the maximum here. The vertex is hk, where h is negative b over 2a. Since b is 20, this gives us negative 20 over 2 times negative 16, which is negative 20 over negative 36. And that reduces to 5/8, which is exactly 0.625 seconds. To find k, we evaluate the original function at that point. With the calculator, this comes out to a pretty nice number, 26¼ feet. This isn't really new. This is a process, however, that only works with quadratic functions. Calculus, however, allows us to find maximums and minimums in an absolute sense for functions that may or may not actually be quadratic. But it's nice to apply a process in a new process to a problem where we already know what the answer is. So we already know that the time to reach the maximum height will be 0.625 seconds, and the maximum height will be 26.25 feet. Now if we take the derivative of the position function, which will be the velocity, that will be negative 32t plus 20, using the power rule. This is the velocity, and if we actually find where the velocity is 0, that will give us the maximum. So this will be 20 equals 32t. 20 over 32 will be t, and that is 5/8. And as we just saw a moment ago, 5/8 is 0.625 seconds. Now evaluating the original function, we actually don't have to do any math here because 0.625 was the number we got for h with the algebra version, and we will arrive at the same 26.25 feet for the maximum height.